Okay, we're going to be doing intersection of two arrays 2. So you're given two integer arrays, nums1 and nums2, and you're supposed to return an array of their intersection. So each element in the result must appear as many times as it shows up in both arrays, and you may return the result in any order. So this is nums1 and nums2, right? And it returns 2, 2. And this is nums1 and nums2. It returns 4, 9, which is here, right? And it appears here, but it only appears once. So you can see here even 9, 4 is accepted. So the first easy way of doing this is to use a hash table. So you store one of them as a hash table, and then you check if that value is in here and it's not set to 0, right? So let's do that first, right? So we convert one of them into a hash table. So you may want to pick the one that is smaller or whatever, but that will be complicating it, and the benefit is marginal, right? Because even if you're able to pick, the code will be so long because you'll have to do like 2 if statements. If nums1 is smaller, then you have code for that. If nums2 is the smaller one, then you just convert either one, right? So we're going to just pick nums1, right? And we're going to convert it into a hash table. We're going to use the counter function, which is part of the collections library. So instead of doing the usual way, we're going to use the counter or whatever. So we'll call it nums1 hash table, right? Is equal to counter. And that's how you counter the capital C, nums1. So now we have a hash table of nums1, right? And this is our test case, right? So this is nums1, nums2. Now we are going to check. We're going to check if we're going to iterate through nums2 and see if if the value in nums2 is in the hash table, right? So we're going to iterate. We'll just grab the value for I in nums2. So we check if it is in the hash table. So if I in nums1 hash table, then we add it to the output. So I forgot to put here the output. So we need an output. So output is equal to that. So if it exists in the hash table, output.append I, and then we decrement the value in the hash table, right? So nums1 hash table at I is minus equals 1, and then we're gonna like keep on doing this until we're done, until we've iterated through nums2, which is this one. And then here we simply return output, right? And it works. But we made a mistake, right? And I wanted to show it to you. And the mistake is here, right? And let me show you. If we submit this, you see it's wrong, because our hash table is smaller, right? So since it's smaller, we're going to have duplicate values. Why? Because of this, right? And let me show you in the code. I'm going to push this to this side, and then we'll pop it up in code, right? So now this is our nums1, and this is our nums2, right? So we're going to place, what helped the other code work was that nums1 was the larger one, and we placed it into the hash table, right? But a more effective way, and I'm going to show you, is to simply check if the value is greater than 0. And let me show you where the duplication comes. So the answer to this input, right? The input where we have 495 and 94984, where nums1 is the smaller one, the answer is actually going to be 9 and 4, right? Because here you have 9 and 4, and here you have 9 and 4 appearing. But it also appears twice, but the intersection, we're not considering duplicate values. We're considering the number of times it appears. So this is our answer, right? But let me show you. So if we look at our code, if we follow this code for our current test case, right? So we convert nums1 into a hash table. It becomes 495111, right? So now we're iterating through nums. We've come here, we're iterating through nums2, and we check. We get our I. If you look at the diagram, our I is here. So now we grab it, which say is 9 in the hash table. Yes, it is. We append it. If you look at the diagram, we've appended 9 and we've set 9 to 0, right? And then we come back here. We're now at 4, right? Is 4 in the hash table? Yes, it is. So we append it to this, and then we set it to 0, right? Because we've subtracted here. And then we come back here. We move our I forward. I forward. Is 9 in the hash table? Yes, it is. And then we're going to set it to -1, right? We have now set it to -1, right? And then here we've appended it as well. So already you can see that we've made a mistake, because 9 appears only. Here in our output it's twice, but it only appears in nums1 once, right? So how do we rectify this? It's very simple. We don't check if it exists, because if we check if it exists, we may count it twice or more, right? So what we do is we check if nums1 hash table at index I is greater than 0, right? Because that will mean that if it is at 0, then that means that we've used up all the occurrences in nums2, right? So this is the solution. If nums1 hash table of this value from nums2 exists and is greater than 1, then we decrement it, right? So let's run this code here. Yes, it works for that input. And it also works for all the other test cases. So this is where we use a hash table. Then the follow-up question was, what if the given arrays are already sorted? How would you optimize your algorithm? Well, if they're already sorted, then the way we optimize, we just use 2 pointers, right? So we assume they are sorted, right? So nums1.sort, nums2.sort, right? So we simply use 2 pointers. And we're going to iterate through nums1 and nums2. This is the pointer for nums1, and this is the pointer for nums2, right? And then we have our output where we'll store our result, and then we do while I is less than length of nums1 and j is less than length of nums2. Why do we use and? Because we want to find the intersection. When you want to find the intersection, it's and. Remember that, right? Because you want to find what's common between both of them. If you want to find union, then or is fine, right? So yeah. So, but we usually use and even when we're trying to like combine all of them in a sorted order, right? So remember that. So now we check if they are equal. Because if they're equal, we're going to just add them and move on, right? And this works because they're already sorted. So if nums at 1 at I is equivalent to nums 2 at j, then we add it to the output, right? So we say output dot append, we can use either or, nums 1 at I. Oh shit, sorry. And then we increment both pointers because we don't want to reuse either of them, right? So I plus equals 1, j plus equals 1. Elif nums 1 at I is larger than nums 2 at I, then that means we don't care about the smaller one, right? Since these are sorted, right? So we increment j. Else, this will mean that nums 2 at j is larger than nums 1 at I, and we don't care about the smaller one. And the reason we don't care about the smaller one is because they're sorted. Both arrays are sorted. So if there's one that is smaller and they're not equal, then that means we won't find a use for it forward because every number forward is going to be larger, right? So I plus equals 1. And then here we simply return the output. Voila. Oh, I made a mistake somewhere. Output nums1.sort j output while I is less than and j is less than if nums, we append 1, we increment if nums 1 is larger. Okay, the mistake was here. This was supposed to be j. Sorry, I wrote I, my bad. Voila, it works, right? So that's how we solve this problem intersection of two arrays. And the runtime complexity for this, because we assume it's already sorted, this will be O length of nums1, the larger of length of nums1 and nums2, but there won't be any space complexity because we assume they're already sorted. The previous one where we used the hash map was the space complexity was the size of the hash map, right? And then the runtime complexity was the length of the array that we iterated. So if it was nums2, then it was the runtime complexity is nums2, and the space complexity is nums1, size of nums1. So they're saying, what if num1 size is small compared to num2 size? Which algorithm is better? Well, if they're already sorted, then obviously this is better, right? This algorithm is better because you don't, it doesn't, like this doesn't matter, you know? The 2 pointers is better. So what if elements of num2 are stored on disk and the memory is limited such that you cannot load all elements into the memory at once? Well, if nums2 is stored on disk and the memory is limited such that, then, okay, this is a bit tricky. So that means you can only load one of them into memory. So are you storing the hash map in memory or on disk? This is tricky. I don't really get what this is saying because either method, I feel like you're loading nums, even if you're iterating with nums1, you're loading it from disk onto memory. So I don't understand this. But yeah, so that's the solution for this. Okay, bye.